So the first thing that we're going to do is talk about what word goes in each bubble. Then we'll talk about what description or definition goes along with it. So our topic here, and I'll just tell you the first word, is to talk about matter. That is our overarching theme. And I'm going to show you how I can classify matter into a whole bunch of different little subcategories. So before we do that, I would like to know, can anybody tell me what matter is? Does anybody know how you would describe that? And there's lots of ways that you could do that. So matter is basically everything. Everything that you see, everything that you don't see, in fact, is matter. And so what a lot of people like to say is that every atom is matter. So everything on our planet that is made up of atoms, which is everything, would be matter. A more scientific definition, if I had to give you things to look for, is that matter is anything that has a mass and occupies a volume. And so it could be very, very tiny, it would still be matter. Now there are two broad categories that I could use to classify matter. And if you look on the screen, there are a bunch of words listed there in no particular order. Does anyone want to take a shot at what the two categories we're going to split matter up into would be? Jacob, why don't you give it a go? That's definitely a set of categories, homogeneous and heterogeneous. And it'll go in a spot, but it's not going to go in this first distinction. There'll be a category that comes before that, but you're right, those are two classifications of one thing. Anyone else want to take a guess? Let's go over here.
Is it pure substance and
It is pure substance and mixture. Pure substance will end up being on the left of my diagram because there are two things that are going to go underneath it. And mixture is going to go over on the right because there's a few other words that are going to follow. So matter can either be a pure substance or a mixture. So let's talk about what would be the difference between those two things. Does anybody know what the difference between a pure substance and a mixture is? So because we're talking already about atoms, I'm going to continue with that discussion. In a pure substance, you have one type of particle. That means that when I look at it, let's say with a microscope, and I have a microscope that's good enough to see molecules, which the ones we have do are not, I would only see one kind of particle. It would be the same particle everywhere. The other thing that's true about a pure substance is that it has constant properties. Now we'll talk about what some properties of substances could be in a few minutes, but a property, for example, would be boiling point. What temperature does it boil at? A pure substance would always have the same value for that. A mixture then would have more than one type of particle, and it would not have constant properties. So for example, pure water is a pure substance. It boils at 100 degrees. That's a property. Salt water is a mixture. Depending how much of it is salt and how much of it is water, the boiling point will be different. And that's what I mean by the properties aren't constant. So that's the definition or the description for a pure substance and for a mixture. Now we'll do pure substance this side first. Does anybody know which two words that are left in our little list there would go in the category pure substance? Element and compound. Those are the two. Element and compound. So we need to distinguish what is the difference between an element and a compound. Now, an element is something that is made up of only one type of atom. And notice on purpose, I use the word atom and not the word particle, because they're not quite the same. Does anyone know what an example of an element would be? There are about 118 of them that you could give. Yes. Iron is an element. So, the symbol for iron is Fe. I love symbols. I like them better than words because they're usually shorter. But iron, which is a solid, so I would put an S next to it, is an element. Something else that is also an element is O2 gas. That's oxygen gas. Notice how there's a 2 there. So I have more than one atom, but I only have one type, and that's the key. So when I'm looking for an element, I'm looking for one symbol. If there's only one symbol in that substance's setup, then it is an element. Now, a compound is fairly similar. A compound has more than one type of atom, but remember, it's a pure substance. It still only has one type of particle. So we're saying that I have 2 or more different atoms, but they're attached to each other. They're in one particle together. A good example of a compound, and there are lots of them that we see in daily life, but H2O, water, is a compound. It has 2 hydrogen and 1 oxygen atoms, but they're attached together. Does anyone want to ask any questions about pure substances, elements, or compounds? So we're going to move to the other side, where we already heard that homogeneous and heterogeneous went together. And they're in fact the 2 kinds of mixtures that you can have. Could anybody tell me the difference between homogeneous or heterogeneous? Yes.
Homogeneous are both it's all the same.
Right.
And
That would be a perfect description. Homogeneous is where everything looks the same. Heterogeneous is where you can see the difference. And so when I look at a homogeneous mixture, it doesn't actually look like there's more than one thing. It looks the same throughout. A heterogeneous mixture is something where I can see the difference, where there are different parts to that particular substance. Now, before we do some examples, I'm just going to fill in the other words that go beneath this. Very frequently, the word solution is used synonymously with a homogeneous mixture. Most of the time, a homogeneous mixture is a solution, usually one where water is the solvent and some sort of solid is the solute. And so solvent and solute go underneath. So I'm saying a solution is kind of like a synonym for a homogeneous mixture a lot of the time. The solvent is the thing that is in greater quantity. The solute is the thing that is in smaller quantity. And very often, the solvent is water. In fact, in really any solution that we would discuss, probably until you got to Chem 30, water would be the solvent. The solute can be a number of different things. For example, I mentioned salt water that you find in the ocean before. In that case, the salt would be the solute. Another way of describing it would be the solute is the thing that gets dissolved. So, since water could be the solvent and salt could be the solute, that means salt water would be a good example of a homogeneous mixture. Now, a heterogeneous mixture can be a number of things. I examples like milk and salad dressing. Now you might say to yourself, oh no, when I look at milk, it just looks like milk. I can't see that there's more than one part. And I would challenge you to not look at homogenized milk that you buy at the store, but to look at actual milk that comes out of a cow. There are very definitely two parts to milk, the cream part and the liquidy part. When you buy it in the store, it's undergone a process to mush that all together and make it look as though it is one. Does anyone have any questions about what matter is or how I could divide it up into subcategories? So the next thing that we're going to talk about are properties that atoms and molecules can have and changes that they can go through. Does anybody need this screen to still be showing? Okay. So we're going to talk about things being chemical or things being physical. And I'm just going to enlarge one side at a time so that you can see it better. The first thing that we're going to talk about are chemical and physical properties. So if I were to talk about any chemical substance at all, and I wanted to describe it, that's what a property is. It's a description. What is this substance like? And there are two types of properties that I could use. I could use chemical properties. And by definition, that would be what chemical reactions that substance can undergo. So chemical properties are the chemical reactions that a substance can undergo. A physical property are characteristics that can cause a physical change, and so I'm going to describe what that means with some examples. So a physical property is something that can cause a physical change. I like to use the word appearance here. Not because it's the only thing that's physical, but it's the one that's the most obvious that you would be able to recognize. A physical property is something that can be identified without reference to another substance. So to identify a chemical property, I have to talk about what it reacts with. To identify a physical property, I'm asking what's something about that substance I can say without mentioning another substance. For example, boiling point, color, density, ductility, conductivity, magnetism, malleability, melting point, phase. Some of these I think you might be aware of, but some of them you might need a brief reminder of what it means. We'll start with boiling point. Now boiling point is one measurement. I could also measure the freezing point of a substance, and we would be talking about relatively the same thing. The boiling point is when a liquid turns into a gas. What temperature does a liquid turn into a gas at? So for any substance, I could measure its boiling point. I don't need to know anything about any other substance to be able to measure that. Color, I think I probably don't need to explain. What color is it? Density, has to do with mass and volume. How much mass does this substance have for a particular amount of volume? Now the next two, ductility and conductivity, people mix up. And I would like to know, does anybody know what the difference between ductility and conductivity is? So if I said copper conducts, what does that mean? Does anyone know what that means? We use it in wire, yeah.
It means
Electricity can pass through it. So conductivity is usually the one that people are familiar with. Conductivity means that usually electrical energy can pass through whatever this thing is. Ductility is not quite the same thing. Ductility is whether or not I can stretch that substance into a long thin piece like a wire. Magnetism, of course, does it have any sort of magnetic properties? Malleability is really similar to ductility. Malleability is whether or not I can bend the substance, so make a different shape out of it without it breaking. And malleability and ductility both have that in common. Can I stretch and can I bend this substance without it cracking? So for example, I could try to bend a piece of uncooked spaghetti, but it would break. It is not malleable. Melting point is down there. It's very similar to boiling point, but it's a different change of state. That is where solid goes to liquid. Phase is another way of talking about really which state something is currently in right now. So that's just a small list of things that are physical properties. Our goal is not that you memorize the definitions of all of the physical properties, but just that you know that they are things about a substance that I can say without having to do a reaction. I can look at the substance just sitting on a table and describe these.
What does it say besides boiling there?
L to G, so liquid to gas. Does anyone else have any questions about the words that are on here? So I'm going to move the screen up in a second so we can look at some pictures. So I will move this back down in just a second. Actually, I'll just try to make this a little smaller so we can see it all. There we go. I think you can see it all now. At the top, above the text on the left, there are 4 pictures. And I would just like for you to take a moment and think, which property is each of those pictures attempting to illustrate? Is it a physical property or a chemical property? And if it's a physical property, perhaps which one? And I made sure that they were all pictures of properties I actually listed down on the bottom. So let's start with the ring. Can anybody think of what property a ring might illustrate to you? And there's more than one that would be correct here. Yes. That would be my objective, to show malleability because I could bend the gold into a particular shape and make the ring. How about the whitewater rafters? What property do you think I might be attempting to illustrate there? Oh, this one's tricky. So they're floating on the water, and the reason that something floats is its density. So that would be this picture here. There's a snowman who is slowly melting there, and since I said the word melting, hopefully it makes sense that I would be trying to illustrate melting point. Now the last picture I'll tell you is a chemical property that I'm illustrating. Does anybody know what this picture of the Statue of Liberty is showing? It wasn't always green. It's rusted. And so this is the reaction with copper and oxygen and water. So this is rusted copper. That's what rusted copper looks like. It forms this actually really nice looking green patina on the outside that protects the rest of the metal underneath it. But that is a chemical property. The fact that copper reacts with oxygen and water to turn green is chemical. I wouldn't be able to describe that without talking about other substances. That's how I know it was a chemical property. Does anyone have any questions about how to tell if something is a chemical or a physical property? So I'm going to move to the other side of the screen. Is there anyone who needs to finish writing something from the left side of the screen before I zoom back in?
What does it say about density there?
About density, it says M and D. I'm trying to represent mass and volume. That's what density is. We will zoom back in so it's bigger and easier to see. And go to the other side now. On the other side, we are talking about changes, not just properties. So a physical change, not property, is something that occurs when the matter changes, but no new substances are produced. And that's really the key. The matter is different than it was before, but I don't have a new substance. I have the same substance that I started with. So a physical change, this occurs when the matter changes, but no new substances are produced. And so the best example I could give you of a physical change is a phase change. Phase change, or a state change, talking about the same thing. Anytime something changes between solid, liquid, and gas, I have the same substance even though the matter has changed. That is a physical change. So for example, freezing and melting, boiling, condensing, sublimation. Now I mentioned melting and boiling on the previous side of the page. Condensing is when you go from gas to liquid. And sublimation is when you go between solid and gas in either direction, but you jump completely over liquid. There's no liquid state. Does anyone have any questions about words that you use to describe a change of state? So a physical change occurs when the matter changes, but I don't have a new substance. State changes are really the obvious ones. But anytime I do something to a substance that hasn't actually caused a chemical reaction, that would be a physical change. So heating something up, cooling it down, mixing it with something else, those are all things that are physical. A chemical change is something that occurs when matter is changed to produce a new substance. That is the key. That is the difference. If a chemical change has occurred, there has to be a new substance produced, something that wasn't there before, but is now. So in the case of the Statue of Liberty, I didn't have that green rust before, and I do now. That's how I know I have a new substance produced. Now sometimes it's not as obvious as a humongous color change. And so there are things that you can look for to help you prove that it really is a chemical change. First of all, the chemical and physical properties that we discussed on this side of the new substance will be different. So even if on the surface it doesn't look like anything has happened, maybe the color hasn't changed, but you measure the density and it's different, or you measure the melting point and it's different, that's some evidence that a chemical change occurred. So a really good example of a chemical change is any time something is burnt. Burning is when you add oxygen, and so sometimes, because you can't see oxygen, people don't realize that it's a chemical reaction. But burning is when you add oxygen to a substance and you get new, different gases formed because of it. Now the thing that's at the end of the list is evidence. And this is probably something that you would have talked about before. I know when I taught grade 9, I still remember it was page 107 of the textbook, in the yellow box at the bottom of the page. There was a list of things you could use for evidence to prove that you had a chemical reaction. If a gas forms, for a gas to form, you might use the word bubble. You might use the word smoke. If light or heat are produced, so in the example of a fire, once the fire starts burning, I can see it and I can feel the heat coming. If the color changes, or if a precipitate forms. Now, any one of these pieces of evidence isn't 100% for sure telling you it's a chemical change. It just means that it's more likely that it is. Now, I'm guessing that you guys know what a gas is, you know what light is, you know what heat is. You probably all know what a color is, but perhaps you might have forgotten what a precipitate is. So I will ask, does anybody know what a precipitate is? Yes. When you shower in the mirror is more foggy. I think you are thinking about a slightly different version of the word. Maybe you're talking about condensation or perspiration. Maybe that's the sense we're going with. Yeah. A precipitate has to do with solids more than it does with gases. I saw another hand up over here. Do you want to give it a go?
Isn't it at the bottom of wherever there's like a solid?
So the idea would be that something solid forms when you didn't have a solid to start with. So you mentioned at the bottom whatever you're mixing. So if I took two solutions and mixed them together and all of a sudden chunky bits started forming at the bottom, that is a precipitate. So a precipitate is a solid that is insoluble. So it's something that doesn't dissolve in a solution. It shows up at the end of a reaction and it is a solid where it wasn't before. Are there any other descriptions on here or words that people would like to find or questions that people would like to ask? So I'll just give people a second, and then I have a few pictures at the top so that we can indicate what kind of evidence there would be in each of those to prove that it really was a chemical change, or perhaps that it's just a physical change and that's all. Oh, the other thing that I'll mention is down here where I say heat and light are produced, heat and light could also be used up in a chemical reaction. So they could be there at the beginning and not be there at the end. So perhaps you might want to make a note that it's really heat or light changes. They could increase or they could decrease. They don't have to just increase. So for example, if something gets colder, that's evidence of a chemical reaction, like one of those cold packs that you put on your knee when you heard it when you're playing sport. I'll come back down to this part with words after if anyone still needed it. I've got 4 pictures up here, and I'd like you to take a second and think, do these represent physical or chemical changes? I have an egg frying on the top, I have a person ripping a piece of paper, I have a campfire, and I have an ice cube in a puddle of water. So we'll start with the egg frying. First of all, let's do a show of hands. Who thinks that this is a physical change? And who thinks that this is a chemical change? Oh, and a few people haven't decided what they think. That's fine. I will tell you right away, this is chemical. And there are a few pieces of evidence that I have to prove to me that it is. And I'm going to ask you to do something very similar to this on a sheet I'll pass out to you in a minute. I know that the color changed. When I cracked my egg, the yolk was yellow, but the white of the egg was all clear, and as you heat it up, it turns white. Color change is definitely evidence that I had a chemical reaction. The second thing, heat. That egg got hotter, obviously because I was cooking it, and so there's heat being used up in the process. That could be another piece of evidence. And then there's a third thing that's hard to know unless you've seen a particular example. But I'm going to tell you this. It's the word irreversible. A lot of the time, a chemical change, I can't undo it. And so if I asked you, can I uncook an egg? You would say, no, that's the silliest thing you ever said. I thought you were smart and had a university degree. And I would say, of course, just kidding, I can't uncook an egg. It underwent a permanent chemical change. And so even if you have evidence, if you're not sure, ask yourself, could I undo it? Could I undo what I just did? And if I could, then it probably isn't a chemical change. Now the second one is a piece of paper being ripped. And I put it second on purpose because it directly follows up the point that I was just making about whether or not things are reversible. If I rip a piece of paper, how many of you would tell me that that is a chemical change? I ripped it. And how many of you would tell me that it's a physical change? And all of these hands are correct. I agree, this is a physical change. And you're going to say, are you kidding? You just told me if it was irreversible that it needs to be chemical. Well, here's an example of where it's not. So keep in mind, evidence is just evidence. None of it is 100%. Even though I can't unrip a piece of paper, I can tape it back together, but I can't unrip it. I don't have a new substance. And so here, my evidence would be no new substance. Now the campfire definitely has to be chemical, and I already listed below why that would be the case. The last thing is the ice cube melting. And I could use pretty much the exact description I used for the paper ripping. It's physical because there's no new substance. Even though I had solid water and now I have liquid water, I still just have water. And if there's no new substance, it has to be a physical change. Does anybody have any questions about either of those two pieces of terminology, chemical or physical